everybody, and welcome to Echo Live. My name is Anna, and of course, I am coming to you from the Michigan Science Center's Echo Distance Learning Program. Today, we have another episode that we are calling Putting the A or the Art in STEAM. So we only recently started adding the A to STEAM, and truly it is just as important as any of the other letters that make up that very important phrase for us here at the Michigan Science Center. So you might be familiar with the phrases science, technology, engineering, and math. And now only recently we've added an A to the mix because art is science too. And art and science really do go hand in hand. And so I wanted to take some time during our show today to talk about how well these two things are intersected and how we really can't have one without the other, because I don't want people to feel that they have to choose between art or science. You really can do both. There are countless careers that rely on arts in science and science in arts. And so we're going to talk a little bit about the myths behind where that kind of divide came from, and then talk about how we can make some really cool art projects. I've got a couple examples here on my table. You could maybe take a guess about what we might be doing a little bit later on today. And I'm going to show you how you can do art and science together at the same time by recreating these different sorts of art projects at home. Now, I'm sure we've all seen a picture very similar, maybe not this exact one, but something pretty similar to the image you see up on the screen behind me. Now, this is denoting your right versus your left brain. And I'm sure we've all heard that kind of distinction before that, we often associate the right brain as being the creative side of the brain. That's where we find things like art and music and creativity and the ability to draw and things like our emotions or our silliness. People often say that those folks who feel strongly about those types of things are more right-brained. And then, of course, we have the other side of our image here, the left side of our brain. And in the left side of the brain, we find things normally like logic and reasoning, maybe science or mathematics or physics, right? And it's really well described here in this image behind me. Now, if you haven't done so already, I would love if people introduce themselves in the chat. And with your introduction, you could maybe tell me your name, where you're watching from, but I'm also curious to know, do you consider yourself to be more right-brained or left-brained? Or maybe you think you're a little bit of both, or maybe you say neither. I'm curious just to find out what you think. And so this is a good way to practice using that chat feature as well. So if you're watching on YouTube or on Facebook or even right here in Zoom, you can, of course, use the chat feature to ask questions throughout the program. Let me know if you have any answers to any of the cool questions I'm going to ask you. Now, I had to choose based on these definitions. Of course, I work at a place called the Michigan Science Center, and I went to college for a science degree. There's a lot of math and problem solving involved. And so by this definition, maybe by denoted behind me, if I had to pick one according to this image, I would probably say that I'm one of those left-brained people. I really love puzzles and problem solving, and I really, really gravitate to things like science, where I can do deep investigations. But I also love to do art. I also love to dance. I wish I was a good singer. I do love to sing, but I promise, I know I've done this to you before, and I promise today will not be one of those days that I decide to hurt your ears by singing here on air. But really, there's no right answer to this question. So people aren't just left-brained or right-brained. We really do use both sides of our brain for almost everything we do. Take, for example, the brain while doing math. And we can really prove which parts of our brain are involved in different processes by taking a look at some different brain scans. And these brain scans will tell us which parts of the human brain are most active when doing a particular task. So in these scans, we have someone who is trying to do some math problems. And you can see that over here in the red, this is telling us that there's more math statements. And over here we have calculations. Green represents numbers. And so those are all denoted in these pictures along the sides. And then the yellow is the area of intersection. So what we can tell, even just by looking at these brain scans, is that we use similar parts of our brain for different processes. One part of our brain can be responsible for many different tasks. And even if we were to split this brain in half down the middle, right, either one of these, we can see that both the left and the right hemispheres, or the left and the right sides of the brain, both of them are active when you're doing math. Now, this is a common misconception that it is rooted in science. Different parts of your brain have different strengths. So math is a complicated topic, right? Math, sometimes we're doing things like counting or calculations, and those types of things might fall more probably on the left side of the brain, those straight calculations. But when we look at things like estimations, so if we're estimating a distance or estimating a number, or more importantly, if we're comparing two numbers to each other, which is another very important skill in any sort of math, that might fall on the right side of your brain. So we really do use both sides for math, right? So saying that you're left-brained, maybe like I thought I was, right, doesn't necessarily align with the scientific research behind this. Evan from Texas thought that perhaps he's more left-brained as well, because I know, Evan, I know you love science, and so maybe you feel like you have to identify that way. But what science is telling us now is that this is really just a myth. We use both sides of our brain for everything. Both hemispheres have a job to do, and tasks are never just as simple as a logic test or a creative test. You're always using both processes at the same time. Say when you are investigating a piece of art, both hemispheres have a role in this as well. So where the right side of the brain is more concerned with the layout of the artwork, kind of taking in the greater large picture, the left brain is more concerned with the fine details. So in this graphic, we have the whole apple tree or the whole painting, and then the left brain is very, very interested in just the small details. So we use both parts of our brain all the time, and you don't have to choose one or the other. We even know this even further, because what were to happen if for some reason you had to remove one hemisphere from the brain? Now, this is only done in extreme cases, if there's already severe damage to one hemisphere of the brain, or if people live with very severe epilepsy or other brain conditions. We can either do a full hemispherectomy, meaning we remove one hemisphere of the brain, or we could do what we call a functional hemispherectomy, which instead of actually physically removing the entire lobe, we would actually cut the corpus callosum, which is kind of the bundle of nerve fibers that connect the two lobes of the brain, or the two left and right hemispheres. When we do this, people can still function. And what we've learned is that the brain is always forming new connections. And so even in a very severe case like this, where an entire hemisphere is removed, although you might lose some brain functions that hemisphere was responsible for, the other hemisphere will start to cope. It will start to adapt, and it will start to learn how to take over some of those tasks that it knows are missing from the other hemisphere. And so people can live their entire lives with only one hemisphere, or they can live their entire lives with the connection between them disconnected. So we can do science and art at the same time. And I know that that's something that I really love to do. So I picked a couple really fun art projects. We're going to talk about how we can actually use science to create some pretty awesome works of art. The first one we're going to try is adapted from a NICE Network activity. If you've never checked out the NICE Network, definitely look them up online. We will post a link to this activity on their website with the description of this program. But this one is called Nebula Spin Art. And I'm sure some of us at home have done spin art before. And they came up with a really cool way to do this using something called a salad spinner. So perhaps you have something like the salad spinner inside your house. There's a few components to it. But basically, we know that when we buy salad or lettuce from the grocery store, that sometimes there can be harmful bacteria on it. So of course you want to rinse it. Once you rinse it, these salad spinners can help us to either mix ingredients or to help dry off our lettuce. I know at least that's what I use it for at home. But what we're going to use this for is an art project. Now, if you have a salad spinner at home, you can use yours for this art project. It'll just be important that you choose to use some very, very washable tempera paint. Stuff that comes off very easily with water, is not going to get stuck to your salad spinner, because of course you want to keep using yours for food. This one is completely designated for science, and so I'm not as worried about it, but I still chose to use washable water-based tempera paint, and this stuff comes off everything. Really, really easy. So even if you were to get it on your clothes or on your carpet or things like that, it does come off, which is why I chose to use it for this activity. Now let's go ahead and I'm going to turn off my virtual background, because unfortunately the salad spinner I have is green. And so it might mess with my virtual background. Oh, I didn't want to switch my camera. We'll get to that activity in just a minute. I'm going to turn off my virtual background. And then let's take an up-close look at some of the components inside. Now, the scientific principle we are going to use in order to make spin art, like you might have done before, has to do with a certain force that's involved when something spins. Now, if I take the top of my salad spinner and place it on here, when I start to push down on the pump, you can see that the basket inside starts to spin. And the faster I push on it, or the harder I push on this top lever, the faster the green part will spin. And it's almost spinning so fast that it's invisible to the naked eye. So we can slow it down using the button here. But of course, we haven't really created any art, right? But it's important that we understand the physics before we actually try making the project itself. Does anyone happen to remember what forces have we talked about when something is spinning? We've mentioned a few here on Echo Live. If you think back to our Give Physics a Spin episode, or maybe thinking about some of the other experiments we've done, I'll give you another hint, because we've talked about this when we've talked about Newton's laws. So we've talked about a few forces. Now, while you consider that question, if you know any spinning forces, you can let me know in the chat. And all I'm going to do in the meantime, while you kind of mull that one over, is I'm going to take some of my tempera paints here, and I'm just going to add a couple drops to the center of my black sheet of paper. So before the program, I just cut some black circles of paper so that I could place them down at the bottom of our salad spinner. Now I'm going to squeeze just a couple drops, and I chose a good variety of colors. I've got yellow, I've got blue, and I've got pink, and maybe I should have chose red, right? Because those would have been our primary colors. But pink is almost like red, and it's maybe a little bit more fun for art projects like this one. So what we are going to be utilizing is a force, and there's a misconception about this force that I want to talk about. Now, when we spin something around, right? When something spins very quickly, say you're being spun very quickly, we can feel definitely some forces. Now, there's a misconception between these two vocabulary words. So everyone go ahead and activate your left hemisphere here for vocabulary. The left hemisphere tells us about vocabulary. And I see that people are starting to tell me in the chat, we're curious about centrifugal force. And I'm so glad you typed that in the chat, Justin, because we are certainly talking about centrifugal force here. Unfortunately, though, that is not a real force in the world of physics. The real term we should be talking about when something is spinning is actually something called centripetal force. And these words are very different, and both of them are important to understand. Now, maybe you've seen something before that looks like this. Has anyone ever been on one of these rides at an amusement park before? Sometimes they're called the gravitron or even the centrifuge, which would definitely lend itself to the word centrifugal force that Justin mentioned here. Basically, the premise behind this ride is you get in and it starts off flat, and as it spins, it starts to push you up against the wall as it spins faster and faster and faster. Eventually, it starts to spin so fast that it can actually angle the entire ride up and down, and you won't fall because that centrifugal force is pushing you against the wall. Now, we said centrifugal force is not necessarily a real force. What it is actually just evidence of inertia. And we've talked about inertia when we've talked about Newton's laws, that when an object in motion, it is in motion, it wants to stay in motion unless it's acted on by an outside force. So these people, when they're spinning, right, they're actually trying to travel in a straight line. But since the ride itself is acting as that outside force and kind of pulling them around, it kind of keeps you pushed up against the wall because you want to continue in a straight path, but the ride is almost fighting you on that. Centripetal force tells us that all of your acceleration is actually towards the center of the ride. But in this case, the force of inertia, that force that's pushing you along a straight path or keeping you on the straight path that you're on, since that force is stronger, you stay flat up against the wall until it slows down, and eventually the force of gravity becomes much stronger, right? So there's all sorts of forces in the universe, but we are talking specifically about this inertia. Now, what I've done is I've taken my paints and I've placed them down here in the center of our paper so that they're all touching. They're all touching right now, and I want to keep them relatively flat. Let's see if I can actually just lift this. But we're going to start to spin them again, and we're going to create some pretty amazing salad spin art, or what NISTET would call Nebula Spin Art, and you're about to find out why. So let's go ahead and give it a spin, and actually that looks pretty cool when the background starts to change. So we'll let it go. And that force, right, that imaginary centrifugal force, which is really inertia when we're talking about it in terms of physics, is starting to pull the paint out towards the edges of the paper. Let's get it spinning a couple more times here. And then let's bring our first project to a slow stop and take a look at the art we've made inside. Ta-da! I'm going to turn off my virtual background. I probably should have just left it off, but I do enjoy the roller coaster ride looking thing. Now we've created some art using that force of inertia, right? The paints wanted to continue along their straight path, and so they were pulled to the outside of the page. But we also see some of the science having to do with color theory. Now we started with, right, yellow, pink, and blue, but now when we look at it, especially if we look at it maybe even a little bit closer, we can see that we're not just left with yellow, pink, and blue in this case. And maybe you remember back to our first Art and STEAM episode where we talked a little bit about color theory. Now we definitely see some color mixing where we have an intersection between our yellow and our blue paint. We've created green. Where we have an intersection between yellow and pink, we have orange. Maybe even a little bit between the pink and the blue, we have purple, right? And this is a really, really easy project that you can do at home. It's not super messy. And if you, like we said, choose to use washable paints, it's just as easy as tossing this and the bottom part in the dishwasher, giving them a good rinse before you use them again. But what if you don't have a salad spinner at home? I know we're all thinking it, and that's a great question, right? Not everyone has a salad spinner. Maybe you're not a vegetable person, but I have a solution for you. You can create your own type of gravitron or centrifuge using just a couple simple materials that I'm pretty sure you can find something like this at home. What I have are two very similar sized metal bowls. Any sort of bowl or even a pie tin would work for this. What's important is that they are circular and that they are approximately the same size. One can be slightly smaller than the other, like I have right here, but close inside is better. Now you might hear that noise. Inside this bottom one, the slightly larger one, I have some marbles. And I've just gone ahead and I've dropped the marbles down inside my larger one so that I can create my own sort of spinning device. And so when I place my smaller bowl on top, I can give it a spin, and you can see that it spins pretty quickly. What we've created is almost like a ball bearing, and so those marbles are rolling underneath our smaller bowl, and so we can create another round of our Nebula Spin Art here. So you'll just want to take your piece of paper, and of course I didn't cut this one small enough. Go ahead and we'll very quickly trim it just a little bit, trying to keep it approximately the same size as our bowl, maybe slightly smaller so that it's easy to get out. Just perfect. You can always tape it down too if you're concerned about something moving. And then in the center, of course, we're just adding a couple drops of our different colored paints. So again, we have our yellow, our pink, and our blue, and you want to keep them all generally pretty close to the center of your project to start. That way we can tell the difference between the beginning of our project and what it looks like at the end. When you're ready, go ahead and give it a spin. Now, of course, our salad spinner works a bit faster and a bit better, so I might have to spin this one a few more times than our salad spinner did. It is starting to work, right? And inertia acts on any object that has mass. And so where our paper has a lot of surface area and is kind of staying flat on the bottom of the pan, our paints are a little bit more viscous, or they have a little bit more flow to them. And so they're more easily able to travel across the paper. Let's give it another spin here. Oh, no, don't stick my fingers in it. That was a close call. All right, working kind of slowly here, but we are seeing some movement of our paints, and I actually want them to kind of move the other way. And so I'd love if you could give this a try at home. Try to create your own sort of gravitron or spinning device for your Nebula Spin Art project. But I have another project for us to try. But again, if you are looking for an activity guide for how you can do this sort of activity at home, I highly recommend checking out the NICE network. They have all sorts of different activity kits around Earth and space concepts, around chemistry, around sustainability. Many of them are very easy to create at home. And they have lots of very cool research that go along with them that connect them to science that's going on in the real world. Now, our next and our last science art project that we're going to try involves this big bin of water over here. And what we are going to do is we are going to do some hydro dipping. Hydro dipping is a process where you utilize the hydrophobic nature of paint in order to create some pretty amazing art. This is an example that I created earlier. This is just a small piece of canvas that I hydro dipped using paint. Now, what's important for this experiment is if you try it at home, you'll need to find some sort of paint that is oil-based, because we've talked about hydrophobic substances before here on Echo Live. And that hydrophobic means that something is afraid of water. I'm sure we've all heard the phrase that oil and water don't mix. It's definitely something that we've investigated a couple times here on the air. And while sometimes we think of that as a bad thing, sometimes it can be a good thing. Say when there's an oil spill in the ocean, since oil is hydrophobic, instead of mixing into the ocean water where lots of our animals live, the oil will always float up at the surface of the water, which can make it a little bit easier to clean up in some cases. So what I have here is a storage tub full of water. And then before the program, before I filled it with water, I actually just put a cut up piece of a garbage bag inside, and that's gonna help to keep my bin clean. But of course, if you have a bin that you don't mind getting paint on, you could skip that step entirely, but I'll show you exactly how that works. Now for this, I chose my oil-based paint to be spray paint. Most acrylic paints are also oil-based, and so they would work for this experiment as well. But I chose spray paint because it's really, really easy to use, but you have to be 18 or older in order to purchase spray paint. So if you're going to try this one at home, of course, have a parent help you with it because you're going to need them to help you get some spray paint. If you have spray paint at home, of course, ask first before you use it and make sure that it is oil-based. Otherwise, when you spray the paint into the water, it will just sink down to the bottom, which is not the effect that we're going for here with this experiment. So of course you want to give your paint cans a little bit of a shake. I did a lot of shaking before the program, and so my paint cans are already pretty shaken up. And what you're going to do is you're just going to start adding paint to the surface of the water. And then once I add a couple layers, I'm going to switch my camera over. A little messy, So definitely you can see that I put down some plastic over the table ahead of time too. I highly recommend doing that, or using this as an excuse to get outside in these last few really nice months of summer. Doing art outside can be really, really fun, and doing science and art together outside at the same time can be even better. So let me switch over my camera now at this point. So I want you to be able to see what's happening inside the bin. You can see that I'm creating layers of paint on the surface of the water, and they kind of move back and forth, fluctuate, but they're always staying on the surface, and they're forming kind of a cool pattern. Now, I chose 3 colors. You'll want to choose at least 2 if you were to try this at home, because we're trying to create kind of some fun swirling patterns, which is already starting to happen. But we can also speed up that process a little bit. Let's add some more blue, add some more purple. All right. But we can also use something like a toothpick in order to kind of swirl our paint around and create even cooler patterns here inside the water. So if you just kind of gently swirl the paint, you can start to create some pretty funky patterns down here inside. And the reason we call this process hydro dipping is we're actually going to start dipping the objects that we want to paint inside this sort of painted water mixture. So get lots of really cool designs going here. All right, now when you're happy with how your hydro dipping pattern looks, then it's time to prepare your item to be hydro dipped. Let me go ahead and I'm going to switch my camera back one more time so I can show you how I've prepared my items before we go ahead and dunk it down inside the bin. Now, what I did before the program is I took my little piece of white canvas and I just attached something like a handle to the back. And so for my handle, you could use string. What I did is I actually just taped a piece of a pipe cleaner to the back, and that's going to allow me to set it down into my water medium and then be able to hold on to it, because this is going to float and we don't necessarily want that. Now, since this canvas is not hydrophobic, since this is not water, our paint is going to cling to the canvas, which is exactly what we want. When you're choosing an item to be hydro dipped, it's important that it's something that your paint is going to stick to, because what we're really relying on here is that the paint wants to stick to your object more than it wants to stick to the surface of the water. So I have my canvas here, and I'm just going to slowly, at a 45-degree angle, dip it down into the water, and hopefully it will grab onto all the paint as it does that. So pick an area in the water where you really like the pattern, where you think it looks really cool. I think this section over here looks really great. And so again, just on a 45-degree angle, slowly dip your object. It could be a canvas. I've seen people who hydro dip things like shoes because the paint will stick to the fabric. And now the tricky part is I could either pull this out of the water completely, but that could mess up the pattern that I've chosen on the front. But instead, or if we don't want to do that, what we can do is we can actually collect all the paint on the surface using something like a scrap piece of wood or some rolled up cardboard. And you can see just how well this process works, right? Since that paint is hydrophobic, it will stick to anything in order to get away from the water. So I can even twist my piece of wood around and it almost pulls the paint in a line off the surface. But the whole time I'm just trying to keep my canvas down under the water, really protecting that pattern down inside. And once you've done a good enough job of kind of clearing the paint on top, then we can take a look at our hydro dipped piece of artwork. Look how cool that turned out. Now, of course, the paint is almost dry because since I cooled it off in the water, it almost dried immediately, but it's still a little bit tacky. And so you'll want to make sure that you don't touch your object while it's getting ready to dry. You can either hang it from your handle or you could set it somewhere where it's going to be very, very safe. But here I have our completed product. And so you can dip anything really, right? Anything that when you read your bottle of paint, find something that it's going to stick to. Canvas is a great way to practice because it holds its shape. It's water resistant, so it's not damaged when I dip it down in the water. But it could also be fun to hydro dip something like a picture frame or a pair of shoes or anything else really that you think might seem kind of fun and cool. Now I need to take off one of my gloves here so that I can go back to operating my computer equipment without getting paint all over everything. We'll switch back to our camera here. And of course, we're just about out of time, but if you have any questions about hydro dipping or how to make your own Nebula Spin Art at home, or about how you might get into doing more science and art projects at home, definitely let me know in the chat. Of course, this is the part of the program where we're going to say a big thank you to Ford and Denso, who have allowed us to bring Echo Live programming to you for free ever since March and through the rest of this year. We are still providing programs on Tuesdays and Thursdays at 2:30 p.m. And right now, until Labor Day, you can still come visit the Michigan Science Center for free until Labor Day. General admission to the Michigan Science Center is free. So if you are local to Metro Detroit, definitely come by, say hi, come for a visit, check out some of our really cool exhibits and hands-on activities that we have for you to try while you're here. All right. No questions coming in just yet. You know, as always, that if you have questions following the program, reach out to us via email, social media. We'd be happy to answer your questions. If you have suggestions for future episodes, also let us know that, and we'd be happy to help you out. Thank you all so much for joining us, and we'll see you on Thursday for